So hi everyone. Today we're going to do an interactive data analysis session. We're going to cover root cause analysis and other things. It's going to be a general root cause analysis session, some of it driven in BioRaptor. So a little bit about me. Oh, the slide. Wait. Okay, so a little bit about me. I'm Yaron. I'm the CTO and co-founder of BioRaptor, in charge of product development and customer relations. Uh, Happy to be here and present this to you. So again, what are we going to cover today? We're going to cover an example scenario about CHO cell and MAB production in CHO cells. I'm going to give you an overview of the data set that we're going to be exploring. We're going to investigate it. We're going to finalize with some takeaways of do's and don'ts and live Q&A. So again, feel free to write your questions in the chat. We're here. Okay, so what's our scenario like? This is a synthetic data set depicting a chop process for MAB productions. In it, there are 25 runs. In them, you can see here that the titer varies quite largely between the runs. And this is not something that you want in your product. Everybody wants this same process robustness where you know what you're going to get. And this is not what's happening here. But we don't know why it's happening because we're using the same media compositions, it's the same operators, it's the same bioreactors, and it's the same facility. So why is product titer all over the place? And this is what we're going to be exploring today. So a little bit about root cause analysis. So if we're being methodic about it, we can divide it into 6 different areas of investigation. So the first would be the equipment. Is there different equipment being used for those different runs? Is there different drifts in the sensors? Another aspect is the materials. Are we using different lots? Are we using different cell banks, or is there a different in the gas supply? We can discuss process. So what's the feeding strategy? Is the DO set point different? Is the DO behaving differently? Is the inoculation OD different and other things? Maybe there is difference in personnel. Maybe different people are doing different things. We can discuss the environment. Is it getting hotter? Is it getting colder? Perhaps there's different HVAC set points being used. And then finally, we can talk about the measurements. Are we using the same measurement methods to understand what we're actually getting? So maybe the process is okay, but we're just measuring it differently. So we're going to cover these aspects in our investigation today, just touching upon each and every one. So just starting with a short question, what do you see as the common culprits for process deviations and fluctuations? Feel free to write the answers in the chat or in the Q&A. Just what do you see as the common culprits? And then please tell us how long does it take you to do root cause analysis, you or your team? So I'll wait a little bit for people to write. I can't see anything, so Edita, I'm relying on you if you have any answers.
Yep. 3. I see a answer posted in Q&A, and they're telling that it usually takes 3 days to consider. Also, it depends, sometimes weeks or months. I want to see the answer who says we don't do it.
Good. I don't know if it's good for them or bad for them.
I don't know. But yeah, that's it.
Okay, so I think this kind of matches what we see with our customers. It takes something between hours to days or sometimes an infinite amount of time because it just doesn't stop. It just doesn't conclude with anything, so it's just an ongoing thing. But unfortunately, we haven't seen at least a company at which this doesn't happen and they don't need it. Okay, so let's start investigating and seeing why it's happening in our dataset. I'll stop sharing to share another screen in a second. And I'm going to be welcoming you to the BioRaptor platform in a second. Okay, so we're going to be using our platform to run the investigation. Most of it can be done in any tool. So this can happen in Excel, this can happen in Jump, uh, except for the end. I'm going to show you some cool things that you can only do in the BioRaptor platform, but really, I'm using our platform for the ease of use. Feel free to do this in any other tool that you like. So, welcome to the BioRaptor platform. So this is the campaign that we're going to be investigating. This is the CHO cell campaign that we're using. In it, there are 25 different runs and with different titers at the end of it. So let's start exploring it. So first of all, let's take one process and start looking at the raw data. So it's always good to start with raw data. And in this case here, you can see the DO and the glucose. So this is the online parameter, the DO coming from the bioreactor, alongside an offline measured parameter, in this case, the glucose. So just to give you a glimpse of what other parameters exist here. So we have the DO, we have the VCD, viable cell density, that's being measured every 24 hours. We have lactate, we have glucose. So this is one process. Now I can go and I can look at several runs and investigate them so I can superimpose them. And one good thing to do usually is to start looking at patterns across those runs. So let's start looking at stuff holistically. Let's go back here and select multiple runs. Let's select all of them. Click investigate. And now I get this big mess here. But now what I can do in this live demo is color by the target. So let's say I want to investigate the relationship between DO and my titer. So all I have to do is select the titer, and this you can do also in Excel and still get this mess. Wait, let me just clear a little bit so I can clear the VCD. As live demos go, this is slow to react. Let's look at it differently. 1 second. So I can go back, pick these three, investigate, and again, let's try to look at the relationship between the DO and the target. So again, I'll be looking at the titer. And you can see that this run has a titer of 8.6, while this run has a titer of 3.5. I don't see any relationship, but this is just looking at a couple of runs. This was just to show you a little bit about the raw data. Let's start thinking about it more holistically. So let's use learn. So what I can do here is I can select all of these runs and start looking at the data holistically. So in this case, I selected the 25 runs. Let's start thinking about the different root cause analysis paradigms or aspects that we've looked at before. And let's see if we can find something here. So first I'm selecting that I want to see the final titer, and let's see if it's related to the equipment being used, right? As one of the six aspects, one of them was equipment. So I'm checking the data and I see that the final titer is not related to equipment because all of those runs were produced in our 100-liter reactor in number one. So this is probably not it. So let's look at another aspect of it. Let's look at the media. So let's look at the glucose lot. Perhaps this is something that adds to it. So let's look at the value of the glucose lot per run. So here you can see I've used three different lots. Nothing. Nothing comes to us, nothing is done. So I think this is what people usually do. We methodically start looking at different process aspects, different lots, different equipments. So let's move on to another aspect of the process. Let's take a look now holistically at the DO. So let's perhaps this is related to the average DO. So I added the DO here and I'm asking the system to bring me the time-weighted average of DO during the run boundaries. And let's see if that's related. Ah, nope, nothing here. You see there is an R square of almost zero. There is no correlation between the average DO during the run and the outcome of it. Okay, let's continue. Let's see what happens. Let's start looking at the operators. Perhaps it's the operator, because there are several people in the plant. And now we're seeing something happening. So we're seeing Dave, Mike, and Sarah. The three of them are running the processes, and we can see that Dave's results are somewhat different than Sarah's. Something is happening here. So we're starting to see a glimpse of an correlation here between what's happening uh, in with different operators. So that's already something that's interesting. So I haven't received an answer from you telling me where do you think the common culprits are, but from what we're seeing, this is one of the first things to look at. Which operator is doing what? So if we continue, we can also take a look at the shift. Perhaps there is a difference between different shifts and what people do. So here we see the day shift and the night shift. I don't know, perhaps there is something here, but not much. So we've covered a few of these. Now it's time to try to see if there are a combination of these factors that allow us to better understand this. So let's remove the stuff that we've shown that doesn't make any sense, and let's see if operator and shift are making more sense. So for this, I'm looking at it and I see that each one is correlated. I'll try to bring and create a model out of it. And you can see that the model tells me, in this case, this is a linear regression model. And you can see that indeed this model actually explains 76% of the changes in titer. You can see that Dave has a positive effect on it. The day shift is also good, while the other operators are doing less well in it than Dave. So here you can see that in a few clicks, I managed to create a model really explaining to me and getting to a root cause of why are these things happening. So, uh, uh, so I think this is something that you can do in any system. This is not something that you need BioRaptor for. What is, I think, unique is that you have all the data coming together in our system, allowing you to view it and really ask the questions and get these answers very, very quickly. Another aspect that you can utilize in our system is the ability to chat with your data. So in this case, what the system does is, wait, I'm just moving this. What I did here is just ask my data, what are the causes for yield fluctuations? And this is something that is utilizing behind the scenes several different aspects. First, it uses the harmonized data model of BioRaptor. Then what we do is we have the background agents which run machine learning algorithms on top of this data, trying to find correlations between different factors and the yield in this case. So here, as I asked this, I received an answer that the primary drivers of yield deviations are the VCD, which we haven't seen ourselves, it's temperature control, and it's something also, something very, very interesting and a little bit surprising. It's the seed preparation timing. So this appears to be correlated with my titer. So, and you can see that the agent also replied with a graph, and you can see something that we haven't seen before. Then there are some operators, I guess, preparing the seed a long time before the actual run, and this has a negative effect on yield. You can see that as I prepare my seed closer to the actual run, I get a better result. So this shows you that the agent did some what we call in data science feature engineering to generate a new feature that allows us to gain insight into the process. So now I can immediately fix this by changing my SOP, or actually not even changing my SOP, by just telling operators that they need to operate within the SOP, but make sure that the seed train is produced closer to the actual run. Uh, so this concludes our root cause analysis investigation. Let me get back to the presentation. Second. So what do we see as the criteria for a perfect bioprocessing world, allowing you to do this kind of root cause analysis quickly? You have to have a very unified data repository where all the data speaks the same language. So you have the offline measurements and the online measurements all at once. You should be able to be comparing and analyzing multiple runs at once and collaborate over it because it takes several teams to bring all this data together, and also real-time monitoring, which helps you not do this 2 months after the process has already concluded, but in real time, that once you have the results in place, you can already ask these questions. And here at BioRaptor, we think we do it pretty well. Uh, we see time to value within 2 weeks from kickoff. Time saved for people and our customers is something between 50 and 80%, both in data insertion, also in report building. Techno-economics speaks for themselves with a 2x ROI, and an annual cost savings is something between 60K and actually $12 million. So takeaways, fluctuations can arise from many different issues. It can either be process data, operational, or actually combinations of them. In this case, we've seen seed preparation and process parameters. Uh, the ease of use drives better outcomes. You can do a lot of what I've shown in Excel, and people are doing it, but as this gets easier and easier to do, you should get better results. And these kind of problem solving sessions will not be a thing that takes you a month, but something that should take minutes or uh, an hour at most. You have to have a unified data platform so that you can really capture both the process parameters and the operational parameters and have an analysis mindset. Just know that you can ask these types of questions and get answers fast so that you can ask many of these questions. All right, so with us talking about questions, now is a good time to see if anyone has a question for us.